In this video, we're going to be finding absolute extrema of a rational function on a closed interval. As we have seen in our notes and in a previous video, we know that I need to plug in the critical points, the critical numbers. So I need to find f of the critical numbers as well as f of the endpoints. Okay. We found in a previous video that the critical numbers for this function were positive 2 and negative 2. I was going to say plus and minus 2. Okay, so what I need to do is I need to find f at positive 2, f at negative 2, and then find f of negative 3 and f of 3 and see which one's the biggest and which one's the smallest. Okay, so let's plug in f of 2. So I'm going to get 2 times 2 is 4, over 4 plus 4 is 8. I get a half. All right, let's plug in negative 2. 2 times negative 2 is a negative 4. Negative 2 squared is 4 plus 4 is 8. I get a negative a half. Ooh, some nice symmetry there. All right, now let's do the same thing with negative 3 and positive 3. All right, so negative 3, I'm going to get 2 times a negative 3 is a negative 6. Negative 3 squared is 9. 9 plus 4 is 13. Oh my goodness. All right, and then f of 3 is going to be a positive 6/13. All right, so I got to know which one's the biggest number, which one's the smallest number. Okay, 6/13 and negative 6/13 should be a little bit smaller than a half. Okay, so if I take my calculator and 6 divided by 13, you will get approximately negative 0.46 and positive 0.46. So we barely beat it. Barely. Okay, so what's going to happen is that this is my absolute min, and this is my absolute max. Okay, so we would say the absolute max is at the point 2 comma a half. My absolute min is at the point negative 2 comma negative 1/2. As I sneak it in. All right, and again, the nice thing about having graphing utilities available, technology, is that we can double check. So if you graph this original function on this closed interval, we should see an absolute max at 2 1/2 and an absolute min at negative 2 negative 1/2. All right, good luck finding absolute extrema.